Okay, so I'm going to start recording. And then today we're just going to do a couple of slides. We're actually not going to do very much. I am going to bounce back and forth today between our slides and our the whiteboard so that you can kind of see what I'm talking about, and I can actually draw it for you as well. So, all right. So again, the notes are on your weekly schedule. I don't think I linked it for one day, but it's the same notes we've been doing. It's on Monday if you want to click on that. Again, I encourage you to have these notes. You know, make copy, do something. You know, take notes, do stuff with it. And then again, especially today, I would encourage you to have a paper pencil and just do the drawings that I do with you about how ionic bonding works. So today we're going to talk about naming and the formulas today, and then a little bit about the properties. And then we're going to practice some today. I've also got a couple questions about the handout from the assignments, the homework assignments. So I want to maybe take a couple minutes to discuss those as well. So, all right, let's share the notes for ionic bonding. And again, as always, if you guys have questions, just make sure you guys ask. So today we're going to talk about nomenclature. Nomenclature is just a big fancy word for how to name and how to figure out the formulas. Okay, so it's just how to name ionic compounds. So ionic compounds are super easy to name. Honestly, there's two steps involved. You provide the name of the cation. The cation is the positive ion because again it has a T in the name for positive, plus sign. Cation is going to be your metals. The metals are always going to be a positive ion. They're going to lose their electrons. That is what makes metals metals, is the fact that they lose electrons. That is a definition of a metal. It loses electrons. Non-metals gain electrons, okay? So the cation is a positive. It's losing the negative. So just think about yourself. If you have negative feelings and you lose them, you become positive, right? You become more positive about it. So that's kind of what's going on here. These atoms have extra valence electrons, especially the rings, and they're going to lose their electrons to try to get 8 total electrons. And again, remember, you can add electrons to get 8, or you can lose electrons to get 8. And again, that 8 is the octet rule for that. So you name the cation, easy, simple. And then you name the anion. The anion is the nonmetal, is the negative ion. Okay, again, it's negative, got an N on there for anion. And remember that the anion ends in IDE. Okay, so I got that right there in parentheses. It ends in IDE. And that's it. There's no numbers, there's no prefixes, there's none of that kind of stuff. You probably heard the term carbon dioxide. That is not an ionic compound. That's a different type of compound that we'll talk about next week. But an ionic compound is just metal, non-metal, ide. Okay, if you look at this example here in this formula, there are 2 chlorines. The 2 is not part of the name. Okay, it's just magnesium. Again, the cation is just a metal. There's no change to it. Magnesium. And then we have chlorine. But since it's a bond and it's an ion, we're going to change that chlorine to chloride. Okay, and so it's IDE. Well, I shouldn't say a lot, but most of the nonmetals, they end in INE for their name. Fluorine, bromine. Okay, you're going to change those names to ide. Fluoride, bromide, chloride. Now you have to kind of watch out for the weird one like oxygen. Oxygen is not oxygenide or anything like that. It's just oxide. I'm not going to count off points if you misspell it or anything like that. Just make sure that you practice. And again, I'm going to give you some hints on quizzes and things like that. Make sure you get them right. All right, so that's it for the naming of ionic compounds. It's just a metal with non-metal and then ide. All right, now the formulas. We've been practicing formulas a little bit, and you're going to practice some more formulas today. So we're going to write the cation formula, write the anion formula. And again, the formula is just the letters that we're talking about. Remember that the cation and anion have charges. Okay, and that's important. Is it +1 charge, -1 charge? What is it? They have charges. And then for your formula, you're simply going to crisscross your charges. Now, this is a shortcut. We've been drawing them in the past, and you guys had a gizmo, and a gizmo showed you what was going on. For a shortcut, if you want to know what the formula is, You take the charges and you crisscross them, and you drop them down into a subscript. So remember on Wednesday we talked about superscript versus subscripting. Those charges are on top, formulas are on bottom for a subscript. Top, bottom. Okay. And so for example, if we look at magnesium nitride, magnesium is a +2 charge, it has 2 valence electrons. Nitrogen is a -3 charge, it has 5 valence electrons, 1 to 3 more to get 8. So nitrogen is -3. We can crisscross them. I need 3 magnesium to make nitrogen happy. Nitrogen, I need 2 magnesium to make that happy. And that is my formula for magnesium nitride. Okay. Now, step number 4, make sure the formula is in the lowest terms. Okay, so for example, 3 to 2, that's the lowest reduction I can go, like reducing, just like in math class when we want to reduce our units and stuff, our variables. Same thing in chemistry. So for example, magnesium oxide, if I crisscross the charge, it's going to be Mg2O2. Well, there's a common factor there too. Reduce them, you get Mg1O1. Okay, so you do want to make sure you reduce your formulas on there. And again, remember for ionics, we're not just talking about one atom binding up with one atom. We're talking about billions of atoms bind up with billions of atoms. But the ratio is 1 to 1, or the ratio is 3 to 2. Okay, in that way. So let's draw some together. Okay, let's practice some. So let's go to our whiteboard, and you guys have paper, pencil at home, I hope. Okay. Let's just practice drawing some of these. So, I don't know. Let's just. How about you guys in the chat box? Pick first person to pick a metal, and let's not do a transition metal. Don't do one that's gonna skip a few. Somebody pick a metal in column 1, 2, or 3. So first metal that pops up in the chat board. Okay, so we have barium. All right, barium works. Okay. So barium, if you pull up the periodic table for barium, barium is in the second column. Barium has 2 valence electrons. So let's draw that real quick. Barium had 2 valence electrons. So it's going to lose those 2 valence electrons. And I'm not going to draw all the rings. I'm just going to draw the first 2 there. Okay. So when barium loses those 2 electrons, it is going to become a +2 charge. And again, we like to add brackets here for that. Okay. All right, let's pick a non-metal that's not in group number 6. It's too easy. Group number 6 is too easy. Pick a non-metal that's not in group number 6. So it needs to be in a 4, 5, 7. All right, I'm going to pick one for you. Okay, fluorine. All right, that works. Fluorine. So fluorine, it's in group 7, so it has 7 valence electrons. So again, I'm not going to draw all the rings. I'm just going to draw the last rings here. All right, so this is the last ring for fluorine here. So fluorine is going to gain 1 electron. Everybody see that right there? Fluorine is going to gain 1 electron. So that makes fluorine a -1 charge. And again, I like to put it in brackets to let me know that I'm talking about an ion. Okay. So if I have these 2 together, I can simply crisscross the charges. And my formula would be Ba1F2. That would be my formula. Now again, these are not charges, so I do not need to put a plus sign or a minus sign on them. Those are the number of ions they're going to have. We also do not need to have a 1 on there because I wrote the atom. I know there's 1 there. Okay. So let's actually show what that means. Okay. So barium has 2 valence electrons, and fluorine has 7 valence electrons. You guys doing this with me? Okay, well, this electron is going to go here. And guess what? I'm not happy. I still have another electron I have to get rid of, right? So I need to draw another fluorine. And then barium is going to donate its electron to that fluorine. Barium got rid of all of its electron. Fluorine gained 1 electron, gained another electron, and then we're done. That is our ionic compound, okay? Now, be careful here. Again, these are not the bond, okay? The bond is this, the positive with the negative. That is the ionic bond. When you have positive and you have negative together, that's what creates a bond, okay? These electrons are leaving barium and going to fluorine. That is not a chemical bond, okay? Fluorine has it now, barium doesn't, okay? But the bond is between barium is positive now, and fluorine is negative. That is the bond, okay? All right, let's try, again, hopefully you did that with me and hopefully it makes sense. Again, this is all we're basically practicing today. We don't really have very many slides. We have a couple more in a second. So let's try one where we need to reduce the formula. So let's do calcium. Calcium had 2 valence electrons. And again, I'm not drawing all the rings, okay? I'm just drawing the last ring. I'm just showing you that there's 2 valence electrons. This is called a Lewis dot structure. We're gonna do more about this next week, but I'm just kind of showing you a little bit of shortcut. Let's do sulfur. Sulfur has 6 valence electrons. All right, you guys see the 6 valence electron? Calcium has 2. So that means that calcium is going to become a +2 charge, going to lose 2. They're going to go away. And sulfur is going to gain 2. 2 are going to go to sulfur. So again, the calcium electron will go to sulfur, and it's done. Calcium's happy, sulfur's happy. So the formula is Ca1S1. Okay. If I did the shortcut method, it would be Ca2S2. Again, we need to reduce the 2's. They can kind of essentially cancel each other out. Reduce the 2's and get CaS. So that's calcium sulfide. That's the name. Calcium sulfide. All right, let's take a look at the worksheet from, it was actually from Friday, but I gave it back to you guys on, actually, I tell you what did you guys have problems with on either the Gizmo or on the homework assignment from Monday? You guys have any issues, any weird stuff? No, I mean, I'll give you the answers. Any specific one, Owen? So this was the handout from, yeah, I don't remember you guys having any names yet. I don't remember you guys naming anything yet. We're gonna do that today. All right, let's share the screen for our work on Friday/Monday. You guys remember this handout here? Katrina, this was what you were asking me about this as well. So the first ones are pretty easy. Let's do D, sodium and nitrogen. So I'm gonna go back to my whiteboard. Sodium and nitrogen. Now again, this was on a Gizmo, so but you can do it on paper. Let's do it right now together. So again, draw this with me. Okay. So we have sodium and we had nitrogen, right? All right. So sodium is Na. Right? It has one valence electron. And if I wanted to draw it, I could draw it. Let's just go ahead and draw it. Let's do different colors. So it had 3 rings. My rings are getting horrible there. So 2 on the first ring, 8 on the second ring. Again, spread them out. And then double up on 5, 6, 7, and 8. Sodium had 1 valence electron. So when it gets rid of that valence electron, that electron now gone. Let me erase this. Boop. How many valence electrons do they have now? It has 8. It's happy. It's satisfied, right? So that's what happened with sodium. Sodium had 1 valence electron. It gets rid of it, and it makes 8. So again, I'm just going to draw the valence electron. Sodium had 1. It's going to get rid of it, right? Nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. Okay. So sodium is going to lose 1, and it's going to become a positive 1 charge. So that's the first column. Sodium is plus 1. Nitrogen is going to gain 1, 2, 3. Nitrogen is going to gain 3. So we're going to turn that into an ion, and it's going to be a plus 3 charge. Now again, for the shortcut, I could just crisscross the charges, and I'll end up with Na3 N1. You see that crisscrossing the charges? Now let's draw it. So again, let me make my arrow a little bit better here. 1 sodium would go there. Another sodium electron would go there. And then another sodium electron would go there. And we can have as many as we want. Sodium got rid of all the electron, got rid of all the electron, got rid of all the electron. And then nitrogen, it added 3. And everybody's happy. Everybody's satisfied. The positive and the negative. Oh, wait, I did something wrong. I did something wrong. What did I do wrong? Find my mistake. Find my error. Oh, in the chat box, find my mistake. It's a pretty obvious mistake. Hey guys, come on. There should be 24 of you in here. Where's my mistake? Hey, somebody got their hand up. Sydney, what's the mistake?
That for the nitrogen, it should be 3 minus, not 3 plus.
Perfect. Yep, that's it. So, yep, that was the mistake there. That should be a 3 minus because I added 3 electrons. So, this is the bond. The plus with the negative, the positive with the negative, and that gives me nothing. Okay, so that was sodium nitrate. And then, Owen, the name of that is just simply sodium. Because, again, the cation does not change. And the anion is going to change into nitride. If you write nitrogenide or something like that, as long as you try to give me the right ending, but again, it's just now a compound. These are now ions. They are not the actual atoms anymore. Okay, that's not sodium anymore. That's not nitrogen anymore. It is a compound of sodium nitride. Okay, you guys want to do another one? Anybody? I mean. I mean, they're all pretty straightforward. Aluminum and oxygen. Aluminum and oxygen gets a little crazy when you do that one because there's a lot of them on there. Yep, that's it. That's it. Owen. It's not really too complicated on it. So aluminum has 3 valence electrons. So aluminum is going to be a +3 charge. And then oxygen has 6 valence electrons. So 6 there. So oxygen is going to be a -2 charge. Again, crisscross your charges, and you'll get Al2O3, which is just aluminum oxide on there. And now to prove it to you, aluminum is going to lose the electron and give it to the oxygen here, because again, it got blanked. This oxygen is happy. It's satisfied now. It has 8. However, the aluminum is not happy, right? So we need another oxygen in here. And the aluminum is going to get rid of its electron to that unpaired electron there. That aluminum is now happy, right? But this oxygen is not happy, right? So we need another aluminum. And again, aluminum had 3 valence electrons. All right, now that oxygen is happy. But that aluminum is not happy. It needs to get rid of its electron again. So I need another oxygen. Oh, what happened? Stop it. Said I lost my internet. All right, here we go. Hopefully I'm back. Hopefully you guys see me. All right, that aluminum not happy, so we're gonna send the electron way over here to this one. Okay, this aluminum is happy. It got rid of all the electron. That oxygen is happy. It gained 2. This oxygen is happy. Gained 2. This oxygen is happy. It gained 2. So what is my formula? Al2. So I have 2 Al, 2 aluminum, and 3 oxygens. So this is the non-shortcut method, but the charges is crisscross. That's the easiest way to get the formula on there. All right, that's about as hard as it gets. But again, if you just draw them and say, okay, this one's going to lose, this one's going to gain, show the arrows, who's losing, who's gaining, should be pretty straightforward. All right. Real quick, I just want to go over the last slide of the notes. That way, we just finished it up. So the characteristics of ionic properties. So ionic compounds, you guys know of ionic compounds. The easiest one I would think of is table salt, just regular salt that's in your kitchen. You pretty much know what that's like. Most ionic compounds are crystals, like the table salt. It's a little white crystal, okay? And it could be a big crystal, but what we use at home is really fine, small crystals. Okay, they're brittle. If I take that crystal and I smash it, it's going to break. It's going to break apart. Okay, they tend to have a high melting point. You're not going to melt that salt crystal. Okay, I don't care if you put it on a stove or not. It's still going to be a crystal. It might burn, but it's not going to melt. It can conduct electrical current because again, ionics have electrons that are moving. Electrons can create electric current. Okay, so the ions are what cause electricity to move, and that's also how you get electrocuted in a bathtub and things like that. Okay? So again, they tend to have crystal structures. These are different types here. Pyrite, also known as fool's gold. Hematite, that is a very blue, iron-rich crystal. A lot of the gems and jewels that you get at home, they are ionic compounds, not diamonds. Well, diamonds are in a sense kind of like an ionic, but they're actual pure carbon. All right, so other properties, again, you can dissolve them in water, and then the positive and the negatives are going to create electrical current, and they can move depending on what is happening inside the water. So ionic compounds can dissolve water, or can conduct electricity in water. When you take a bath and you accidentally drop the toaster in the bathtub, which I don't recommend doing, the water did not conduct electricity. Okay, pure water doesn't conduct electricity. It's the stuff in water that conducts electricity. Okay, so that's why you have to be really careful with. There's all kinds of stuff in our water, especially in the bathtub. There's all kinds of stuff in there. That's what's conducting electricity. Pure water does not conduct electricity at all. So that's just what you have to be mindful of. All right, that is it for me. You guys have a homework assignment that you guys can work on right now. Again, we have about, I don't know how much time we got here. We got about 10 minutes. There's a homework assignment. Now, it is a quiz looking thing. Let's go back to the weekly schedule. It is a Canvas looking quiz, okay? And it's going to ask you some questions about, naming and things like that. And, so again, you're just going to kind of select, what is the anion, what is the, okay? You're going to kind of select, what is what for the formulas here. Now, on this handout, okay, right? So how many ALs or how many Cs you're going to have? This is going to get you some practice for your quiz coming up, okay? So this homework quiz assignment is going to get you ready for the real quiz. Okay? So again, on this, you can take it as many times as you need to. You'll get the highest score just like any homework assignment. All right, I will be here to answer any questions that you need. If you guys have questions, just reach out, ask, and I'll help you out with your assignment. All right, that's your word for next 10 minutes or so. I think there's only 8 problems. There's like 8 or 12 problems. All right, so, all right, get to work. And again, we're going to have a quiz tomorrow, probably, hopefully. So do the homework assignment. It will prepare you for the quiz. I'm telling you, the exact questions, the exact questions from the homework assignment you're going to see again tomorrow or Friday. Okay, so do them, learn from your mistakes, and then let me know if you have any questions. How we doing? We doing okay? Working on that? Anything weird or difficult? You want to do the first one together? That way you kind of understand how it's going to work. Yes, yes, you can. Help us. Help me. All right, so if we do if we just do that first one real quick, just to make sure we understand. When I missed your last question. Distilled water, non-conductive. Yep. And again, it has to be pure water. Even if there are 2 ions in there, then it becomes conductive. But pure water is non-conductive. All right, so on the first one here, this is asking what would be the formula. And so this is just a crisscross. So if I crisscross it, I'm going to give the 3 to Al. I'm going to give the 3 to N. So if I do Al, so Al is going to be my first, so it's my anion. And I'm going to give it 3. And then N, I'm going to give it 3. However, what's wrong with that? That's not right. That's not correct. It's not about the negative anymore. Remember, these numbers aren't charges anymore. But we have a ratio of 3 to 3. That gets reduced down, right? So that's the ratio of 1 to 1. Okay, so that's a ratio of 1 to 1. Okay, so a 3 to 3 cancel each other out to 1 to 1. So if we do the next one here, I have potassium and sulfur. So the 2 is going to go to potassium, and the 1 from potassium is going to go to sulfur. So my first one is going to be my potassium, and I'm going to get a 2 on that from the sulfur, right? I'm going to crisscross my charges. So then the B is going to be sulfur right here, and I'm going to get the 1 from the potassium in order to get that formula there. And again, it doesn't look like there's a 1 there, but there is a 1 because it's just a plus sign on that. So on this one here, I have aluminum and I have chlorine. Chlorine is going to give, again, crisscross the charges. Chlorine is going to give the aluminum 1. Aluminum is going to give the chlorine 3. And so I do aluminum first. Remember, metals always come first. Metal is going to get the 1. And then chlorine comes second, and it's going to get a 3 on that, right? It's going to crisscross those charges, get 3. All right, I'm going to skip those because I think you guys get the idea. All right, so what is the name of this? So remember the first element, there's no change. That's beryllium. So we can already eliminate A and C, okay? It's just beryllium. There's no change on the first one. The second one is going to get changed to ide. Okay, so we need to look for an ide. So it's got to be B or C here for ide. Again, it's not berylliide, bromide. It's just beryllium bromide, the last name on that, right? Again, for the name here, it's just the first element comes first, and then the second element ends in ide. I'm going to fast forward to these. These are all pretty basic, pretty simple. Okay. All right. All right. So this one here, again, what is the formula? So we have barium and sulfide. I did not give you the charges this time, so you have to look up here. Barium is a +2. Sulfur is a -2. So if I crisscross the charges, they're going to be 2, 2, right? So I'm going to start with the first one. I'm going to give it a 2. I'm going to go to the second one, and I'm going to give it a 2. However, what's wrong with that? Okay. So the 2 and the 2 are going to cancel each other out, right? They can be reduced. So that's going to be a 1 to a 1. Okay, so barium can get 1, sulfur can get 1 on that. If I do the next one here, barium and phosphide. Barium is a +2. Phosphorus is over here, it's a -3. So phosphorus are going to give 3 to barium. Barium can give 2 to phosphorus. So again, I'm going to go to barium. I'm going to get the 3 from the phosphorus this time. The phosphorus is going to get the 2 from the barium. All right, I gave you a bunch of answers, so hopefully that makes sense on that. So, all right, I'm going to stop sharing. I think our screen's good here, and I think our time is up anyways. Yep. So, yep, 5 to 5 will reduce to, yep.